Hi, today we are going to see doubly linked list. So as far as the doubly linked list is concerned, a doubly linked list is a two-way list in which each node has two pointers, the next and the previous. There are two pointers are there, the next and previous, that have reference to both the next node and the previous node respectively. For example, so this is the representation of doubly linked list. So usually the doubly linked list, whatever the linked list, whether doubly or singly, the first node which is connected to the head node. So the first node which is connected to head, so each and every node here there are three portions of that. One is previous, another one is data, third one is next. So each and every node have three partitions. In a singly linked list, only two partitions are there. One is a data, another one is next link. So here in this doubly linked list, we are able to refer the previous node as well as next node. So that's why there are three partitions are there, and previous, data and next. For example, I am taking here, I am considering three nodes here, and these three nodes, the first node which is connected to head, so it is connected here. Then this node is connected, the first node is connected to second node through this pointer, second node is connected to third node through this pointer, and third node is connected to second node through this pointer, and second node is connected to first node through this pointer. Okay, so this is what the representation of doubly linked list. For a better understanding, I am giving you the memory representation. According to memory representation, I am giving these three nodes here. For example, it is connected to, what is it, the first node. First node, it is nothing but, suppose just imagine that this is the first node, and the second one is fifth node. This is the fifth node, and next one is sixth node. This is the sixth node. For example, you are taking like this. Okay. First node, fifth node, sixth node. We already know that in a linked list, the nodes are not continuous. It is, what is it? According to the availability of memory, we are taking whatever the node and we are connecting that node to the previous node. So we already know that. So that's why this is not continuous. What about, suppose I am taking this memory representation. In this representation, previous, data, next. You consider this as a single node. This as a single node. Okay. So suppose I am imitating this same value here. What is it? This is -1. This is -1. Why it is -1? There is no previous node. Previous only head. So head it is connected to first node. So there is no previous node. So that's why it is -1. What is the data value? Data value is 12 here. Data value is 12. And what is the next node? Next node is 5 here. Is the point here? Whenever we are taking this value, next node value is 5. So directly we go to the fifth node. What is that? Fifth node. So what is fifth node? Fifth node, previous, what is the previous value? Previous value is 1 here. Why it is 1? This node is connected to, previously it is connected to first node. So that's why 1. What is the value of this node? Value of this node it is 25. And what about the next node? Next node is 6. Next node is 6. So immediately we come to sixth node. As far as sixth node is concerned, what is the previous node? Previous node is 5. So what is 5? What is the data value? Data value it is 40. And what about the next node? There is no next node here. So that's why it is -1. So 1 here. So this is what the memory representation of the particular three nodes. Okay. So through this way only we are going to examine each and every node. What about the first node? I am getting the first node memory address from head and I am coming here. After evaluating this node, next is 5. So that's why I go to fifth node. So fifth node is here. Go to 5 through this link. Okay, through this link. And what is the data? It is 26, 25. After evaluating the data, we go for next node. What is the next node link? It is 6. So that's why I go here. Whenever after reaching here, suppose I want to take the previous node, how can I take? What is it? The previous node here it is mentioned here. this is previous, and at the time of accessing forward method, I am taking next, and whenever I reach any node, I want to come back, so I am taking the previous column. So what is previous node value? It is 5. So that's why I am coming here through this link. And what about the previous node value? 1. So I come here like this. So through this way, in a doubly linked list, I am able to go forward as well as backward. I am able to come backward also through two separate links, forward link and backward link. So that's why it is called as next. This is next and previous, this is previous. Okay. So through this way, we are evaluating the doubly linked list. Okay. Now, what are all the operations are there according to doubly linked list? There are 8 operations are there. First one is insertion. There are 3 insertions are there. These 3 we call it as insertion. These 3 we call it as deletion. And these 2 it is called searching and traversing. So searching and traversing. What do you mean by insertion? Insertion, it is again 3 categories. Insertion at the beginning, insertion at the end, insertion after specified node, as we already saw in the singly linked list. Okay. And what about deletion? Again, as per the singly linked list, here also there are 3 types of deletion is possible. One is deletion at the beginning, deletion at the end, then deletion after specified node. So this is comes under the deletion. And apart from insertion and deletion, other 2 operations are also there. One is searching a particular node, searching a particular data in a doubly linked list, and traversing from first to last. Traversing, it is nothing but, usually traversing it is nothing but we go from head to last node. This is, we call it as traverse. And here there are forward traversing is also possible, backward is also possible. Without forward, we are unable to come backward because the lead node is the head node here. From head only, I am able to go to the first node. From first node, I am able to go to the second node. From second node, I am able to go to the third node according to the next value. Whenever I reach the last node, again I am able to come from third node to second node to first node. So this is also one traversing. So forward traversing, backward traversing, it is possible only from the head node. Okay. So these are all the overall idea of doubly linked list. In our succeeding videos, we are going to see what is insertion, how insertion takes place in the doubly linked list, and deletion and searching as well as traversing. Thank you.